Hello, good evening all. So, we have started our biomolecules last time. Now, today, after doing that part, what we have done? What is the definition of carbohydrates? Its old definition. What are the limitation of that old definition? And then we have started that modern definition. Then classification of carbohydrates like monosaccharide, disaccharides, oligosaccharides, then tetrasaccharides, polysaccharides. Am I right? Then we have covered those sugars and non-sugars, or reducing and non-reducing sugars. Then structures of pentoses and hexoses, monosaccharides. Now today we will start glucose. Glucose. So glucose is also known as dextrose, or it is also called grape sugar, and its molecular formula is C6H12O6. Am I right? You all know it. Now, glucose, it occurs in nature in free state as well as in combined state, that we have done in sucrose, in maltose, yes, in lactose even. Glucose is present in combined state, and glucose as such is also present in nature. Okay, it always occurs in large quantities in ripe grapes. That is why it is also called grape sugar. Okay, ripe grapes, we can prepare it. It occurs in large quantities in ripe grapes, right? That's why it's called grape sugar. Okay, it also occurs in honey and most of the sweet fruits. Mangoes, apples, even peaches. Okay, all means sweet fruits. In all the sweet fruits there is a content of glucose. Okay, in the combined state, it occurs in all disaccharides, even starch, cellulose, there is a glucose. So in all polysaccharides even this glucose is present. So let us do its preparation of glucose. So glucose can be prepared from sucrose by the hydrolysis of sucrose, or by the hydrolysis of starch, because sucrose is made up of two molecules, that is, one is glucose and other is fructose. That is also called inversion of cane sugar. So when sucrose, preparation from sucrose. Okay, so C12H22O11, that is the formula of sucrose. Okay, so when it is hydrolyzed in dilute HCl, then we get one molecule of glucose and one molecule of fructose. Both have same formula, means it gives equimolar mixture of glucose and fructose. Okay, so that is obtained from starch. So this is the first preparation. This is also called inversion of cane sugar. Okay, because this sucrose has dextro rotation, glucose has dextro, and fructose has levo rotation, but levo rotation of fructose is greater than dextro rotation of glucose. So overall it is mixture is levo rotatory. Okay, that's why there is a inversion of rotation. Okay, from dextro to levo. That's why it is called inversion of cane sugar. Now second is from starch. What is the formula of starch? Starch is a polysaccharide. So generally in commercial level it is prepared from starch. We hydrolyze it by using dilute HCl or H2SO4 at 393 Kelvin temperature, then under pressure. So we get C6H12O6, that is molecules of glucose are obtained. Okay. So that means we can prepare glucose by the acidic catalyzed hydrolysis of sucrose or starch, right? Now let us discuss its structure. So this is the method of preparation. Now open chain structure of glucose. Open chain structure, yes, 2 to 3 atmosphere pressure, but if you skip to right, it's okay, under pressure, okay. So open chain structure. So you know glucose जो है it is, glucose is aldohexose. Glucose is aldohexose. Aldohexose means, yes, what do you mean by aldohexose? बोलो बेटा, what do you mean by aldohexose? Yes. बोलो जल्दी. Aldohexose means yes, hexose means 6 carbon, that's okay. And aldehyde group and aldehydic group, okay, means it has aldehydic group and 6 carbons. Okay. Good evening, Harshil. So it is a monomer. Obviously it is a simple structure. It is a monomer of many polysaccharides, I mean starch, cellulose. Even it is present in disaccharides, even like sucrose, maltose, lactose. Okay. So its open chain structure जो है, that contains one aldehyde group and one primary alcoholic group, 4 secondary alcoholic group. It is like this: CHO, CHOH4, right, and CH2OH. Okay. So this is primary alcoholic group, and these are 2-degree alcoholic groups, and aldehyde group. Okay, good. Good evening, Harshil. Good evening, Rishi. Okay. Yes, अच्छा, आशीष, चरित्र, वसंत, यश, प्रहर्ष, कश्मीरा, okay, Ketul, Harshil and Rishi. Okay, good evening to all. So now we have to prove by reactions, chemical reactions, that it has one aldehyde group, it has secondary alcoholic group and 4 secondary alcoholic groups and one primary alcoholic group. We have to prove by chemical reactions. Okay, and this open chain structure of glucose was proposed by Bayer. Okay, no, it's so it's not like that. Cold is, I have I'm suffering from cold. But it's okay. Okay, so first systematic means we are assigned the structure, okay, by the evidences. Okay, we are collecting the evidences by chemical reactions, right? So first is molecular formula. So you know all that molecular formula of glucose is, what is molecular formula of glucose? Its molecular formula is C6H12O6. Then how do we prove that it has straight chain? So when we reduce this whole thing, this glucose, when glucose is reduced by using Hi in red phosphorus, then we get normal hexane. One, two, three. Yes, normal hexane. We get normal hexane. Thank you, beta. Thank you very much. I appreciate that you are taking care of me. Okay. So glucose, when it is reduced or on reduction with Hi and red phosphorus, we get normal hexane, or even small amount of 2-iodohexane is also formed. So it proves that all the 6 carbons are present in straight chain. All the 6 carbons are present in straight chain. Okay, done. Now third one. Now we have to prove that, first see, we have proved that it has 6 carbons, that is clear from molecular formula. Then all the 6 carbons are in the straight chain, that is proved by the second one. Okay. Now third, presence of an aldehyde group. To prove it that it has an aldehyde group, that means it should give reactions related to aldehyde group. Okay. For example, it can, when aldehyde is this glucose is treated with hydroxylamine or HCN, in both cases it will react and we get cyanohydrine with HCN and oxime with hydroxylamine. It proves that it has an aldehyde group, means carbonyl group is there. See, CHOHCN, okay, so that is glucose cyanohydrine, glucose cyanohydrine, okay, and with NH2OH, the water is removed and we get this product, that is glucose oxime. Okay. So this reaction suggests that glucose contains a carbonyl group, means C double bond O group is present. Okay. These are the typical reactions of carbonyl group. Now to prove that this carbonyl group is aldehyde only, what we do, when this glucose is oxidized with mild oxidizing agent, so when glucose it is oxidized with mild oxidizing agent like bromine water, it gives gluconic acid, and this acid contains same number of carbon atoms as present in the glucose. So it means this carbonyl group, this suggests that carbonyl group present in glucose is an aldehydic group, because when it is, first of all, aldehyde is the only one out of aldehyde and ketone which can be oxidized with mild oxidizing agent. Okay. So obviously it is glucose, it is aldehyde group, or if it is a ketone, then we cannot get acid with same number of carbons. Okay. As acid is formed with same number of carbon atom as in aldehyde, as in glucose, that implies that it carbonyl group is aldehydic. Okay. Now next one, presence of 5 hydroxyl group. See, in first case, what we do? We have done in the first point that indicates it has 6 carbons. Then in the second point with red phosphorus and HI, when it is reduced, it gives normal hexane and 2-iodohexane. It proves that it has 6 carbon atoms in the straight chain. Then this glucose can react with HCN to form cyanohydrine, with hydroxylamine to give oxime. It indicates it has carbonyl group, and it can be it is oxidized with mild oxidizing agent and give acid with the same number of carbons. It suggests that the carbonyl group present in glucose is aldehydic. Okay. Now to prove that it has 5 hydroxyl groups, what we do, that this aldehyde, when it react with acetic anhydride, this is acetic anhydride, then it gives glucose pentaacetate of glucose. It gives glucose pentaacetate. So this proves that it has, see, it gives glucose pentaacetate. So as pentaacetate is formed, this confirms that glucose contains 5 OH groups, because you know all the 5 OH groups should be on the different carbons, because if even two sorry you know, if even 2 OH groups are present on the same carbon, it is highly unstable. You know that if we have 2 OH groups on the same carbon, then what happened? Water is removed and we get aldehyde or ketone. If 3 OH groups are there, we get acid. So OH groups should not be on the same carbon. Okay, that means 5 OH groups are present on the 5 carbons, because glucose is a stable molecule. Okay, now we have proved by reaction with acetic anhydride, it is esterification, simple esterification reaction, right? This is esterification reaction. Because this OH and this part react and we get 5 acetic acid at the same time. Okay. Now next one, presence of one primary alcoholic group. Sorry beta, presence of one primary alcoholic group. So presence of one primary alcoholic group, you know, on oxidation with HNO3, so this is glucose. Okay, so glucose on oxidation with HNO3, what it give? It gives saccharic acid. Okay, with dilute HNO3, it gives saccharic acid. See, with bromine water, with wait, I'll let you know when to stop. Okay, see, with dilute HNO3, glucose will give saccharic acid or even gluconic acid. Gluconic acid will also give saccharic acid. It means, you know, one CHO, we have proved that it has CHO group, but obviously primary alcoholic group can give COH. Okay, so primary alcoholic group is always present at the end of the carbon chain. So in this way we have proved, okay, that it has, see, one CHO group, 5 OH. So obviously they are on the different carbons, and one primary alcoholic group. ओके बेटा, तो इतना ही रखते हैं आज, है ना. नेक्स्ट टाइम वी विल कैरी आउट द नेक्स्ट पार्ट. ओके, थैंक यू सो मच फॉर योर caring nature. I appreciate that. Bye bye बेटा.